Upregulation and downregulation. We go to that?
Yeah.
Okay.
Like IPSPs and EPSPs.
No, upregulation and downregulation would be increasing or decreasing sensitivity of a cell to a hormone by either making more receptors or removing receptors.
Okay.
That's downregulation and upregulation.
So which one?
So upregulation would be creating more. That's upregulation.
What's the IPSPs and the, like you said, you make IPSPs, but then you can make the EPSPs.
That's this.
Oh, okay.
Yeah.
So then down would be?
Down would be endocytosis and then just destroyed inside here. Okay, so that increases or decreases the sensitivity of the cells to the hormones. Okay, you can either make more receptors, upregulation, or you can pull the receptors out of the membrane and get rid of them. That's downregulation. Okay, increased sensitivity. Think about it like this: if you're increasing your sensitivity, you're upregulating, right? If you're decreasing your sensitivity, you're downregulating. And that's that one, that's that question. We're halfway through this thing already.
Sweet.
It's that one. These three questions are about upregulation and downregulation. These three. Water soluble. Okay, so water soluble, let's talk about location of receptors. Where's a water soluble receptor going to be located on the target?
Membrane.
Yes, on the cell membrane, right? And it's important to understand like why, not just memorize it, but understand why. So the reason it's going to be
can't go through the
it can't go through the cell membrane, right? It's not lipid soluble, it's water soluble. So this is going to be located here, right? So a water soluble receptor is going to be located on the cell membrane, right? Lipid soluble
in the nucleus
or in the cytoplasm, it varies, right? Lipid solubles can be located right inside the nucleus because the lipid solubles, they go right through the membrane, right through the nuclear membrane. They're lipid soluble. They don't need a channel. They don't need help getting in.
Are there cells that have both water and lipid soluble?
Yes,
okay.
Most cells do.
Oh, okay.
Yeah. Yep. Okay. Oh, if it's a membrane-bound receptor, it's going to be associated with a G protein complex. These ones inside, not. So water soluble ones have the G protein complex, that alpha, beta, gamma. Okay, and we'll talk about those MOAs in a minute, the modes of actions of those. Okay, so water soluble, G protein. Water soluble in the cell membrane. Lipid soluble, no G protein. Lipid soluble in the nucleus or inside the cell somewhere. Yeah, and then know the steps that happen after this attaches. All right, so know the steps that happen. So the receptor is going to bind to a hormone, and then this is going to separate. Remember all that stuff? Look over that stuff.
Steps for what?
Steps for what happens to the G protein after a hormone attached to the receptor. And that's a sequential question on here, right? Like here are the steps, which one shows them in the correct order.
Mm-hmm.
Okay? What's that?
Like, can you tell us the correct order?
Yeah. I was just trying to hurry up and get through the whole thing, but you want me to spend time on that one?
Let's get through the whole thing and then if we have
Yeah,
time.
but if I don't get there at the end, tell me to come back, okay? Yeah. But if I don't get there, look that up.
Yeah.
All right, cyclic AMP. What's the role of cyclic AMP? So cyclic AMP, its role, so cyclic AMP, CAMP, which is basically an ATP with two phosphates removed, right? So you got ATP, ADP, and then AMP. So cyclic AMP, its role is a secondary messenger, so it attaches to protein kinase. Okay, and then that's going to cause some bigger reaction in the cell. Okay. AMP. Cascade, remember cascade? So cascade is where you have one activity that multiplies as it steps down. Okay, that's a cascade effect.
Can you give an example?
Yeah. Okay, an example. Yeah, so hormone, receptor, let's say G protein. Okay, and there's several of those off this one receptor.
Mm-hmm.
They're going to create a whole bunch of cyclic AMP. Cyclic AMPs, all of these. Each one of these is going to react with many protein kinases.
Ah.
Okay?
That's the
Cascade. Yeah. Okay. Got that. Nuclear receptor, good there. Oh, what happens? So after this guy binds, after this hormone comes in, this lipid-soluble hormone comes in through the membrane, through the nuclear membrane, and binds to the nuclear receptor, what's it going to do next? What's it going to make?
Oh, mRNA.
mRNA.
To go
So
to the
transcription is
ribosomes.
going to happen next. Okay? So transcription, and then that's going to move out to here for translation. That's going to make your proteins. Okay? Okay. Yep, next one is just the steps of that. Steps of this. Like, which one of these shows you the proper order? Steroids are lipid soluble. An example of lipid soluble is steroids. That's a question. That's the answer to a question. Lipids are
Steroids.
Steroids are lipid soluble. Matching. This section of matching is neuropeptide, autocrine, endocrine, paracrine, and neurotransmitter. So this is the first thing we did. First thing we talked about. There's a matching section for that. Neuropeptide. So if it says neuro in front of it, that just means it's a peptide that comes from a neuron. Neuropeptide. Yep. Endocrine, autocrine, paracrine, neurotransmitter, and neuropeptide. And then these next, 7 questions deal with, okay, which one of these is associated with a lipid-soluble hormone, which one of these is associated with the water-soluble. Just remember, the water-solubles have the G proteins and everything that goes along with them. Lipid-solubles are very, very simple. They come in, they go through, they go to the nuclear receptor, transcription, translation.
That's it.
That's it.
Wait, you said that was lipid.
That's lipid. Yep. Anything else is going to be associated with water soluble. All the G proteins, all the protein kinases, all that intracellular calcium stores, all that stuff, that's all water soluble.
The water is complicated.
Yes.
With the protein.
Correct. Okay, completion. These are just one word, fill in the blanks. Okay, so what would this be known as? This cell. Or
Target cell?
What is it?
Target cell?
Target cell. Yeah, know what a target cell is. Target cells, target tissues. Yeah, we went over those. Near the end here. Oh, if, I'm using the word a lot, but I don't know if I talked about it. So if something is released into the body, but it's not, its purpose isn't to leave the body, but to stay in the body, that's called a secretion. Okay, I've been saying it a lot, but excretions are destined to leave the body, like sweat. Right? Secretions are created, and they're meant to stay in the body. Okay? That one went over that. Yep, so humoral control versus neuronal control. That's a question on there. We already talked about that. Up regulation, down regulation. Yeah, did that one. Humoral control, episodic. All right, that's it.
Can you go back to the steps?
Yeah, which one was that?
The G protein after.
Yep, G protein. G protein.
Don't they all split and then the gamma just attaches to the... The
You
gamma
feel better
attach-
about this now?
Yeah.
Yeah.
The gamma attaches to something, creating the.
Where was
Oh,
that? Ow. Oh, here. After the water soluble, those steps?
it's
Yeah,
steps after
yeah.
G protein.
Okay.
Yeah, steps after G protein.
Okay. So the steps are, so this is steps after the water soluble binds to
It's
the
a receptor.
Okay. So the G protein is going to, hold on, I think this answer key's not right. Okay, yep. Ready? Are you gonna rate? You guys gonna rate it or just listen? How slow do you want me to go?
Kind of slow.
Kind of slow. All right.
Not fast.
All right. All right. So the G protein subunits bind to the receptor. That's first. Next, GTP, which is guanosine triphosphate, is going to bind to the alpha subunit. Remember, the alpha separates. So GTP is going to bind to the alpha subunit, replacing GDP. Remember in the picture, that's that arrow. Comes up and back down. GDP, guanosine diphosphate. The third step, the G protein subunits are going to separate from the receptor. Now it's sliding.
The what stuff?
The G protein subunits separate from the receptor. And then alpha is going to separate. Next step, alpha is going to separate. And then finally, the alpha subunit
Attaches.
GTP complex. So it's alpha. We got our receptor, right? And alpha is going to separate, so it's going to do, right? Alpha is going to separate. So this alpha and GTP complex. That's the alpha GTP complex, right? That guy. Alpha GTP complex is going to alter the cell activity.
Alters the what?
Cell activity. Good? Feel good?
Are there any like diagrams
No.
from
No?
Is there anything on there about the APG and the PPG?
PPG? I mean, IP2 and IP3?
No, isn't it the anterior pituitary
Oh.
gland and the?
No, surprisingly.
Okay.
No. Yeah. I did that whole drawing over there. I didn't put anything on the exam about it.
Okay.
Yeah, that's what I was wondering.
Right.
about.
Like hypothalamus, to
Yeah,
releasing
that kind of
hormones
stuff.
to the anterior pituitary,
Okay.
to tropic hormone, to endocrine cell, to blood, to target cell. Yep. Maybe I'll make that a bonus question.
Yeah.
Oh, that's.
Oh, sure.